In this demonstration, we have 4 jars. One is full of sugar, the next one is 2/3 full, 1/3 full and empty. Now, we know that heavy objects and light objects fall vertically at the same rate. But what about these rolling down an incline? Will the heavier one get there first, or perhaps last? Or maybe they all arrive at the same time. So we'll set it up, let them roll and see what happens. This is the heaviest one. It's completely full. This is 2/3 full. This one is 1/3 full. And this is the jar that has no sugar at all. So if we release them to roll at the one time and observe the outcome. Well, certainly they didn't all arrive at the one time, and indeed this one didn't arrive at all. It stopped after rolling a certain amount of time. So how can we account for the variation? Well, if you imagine a bicycle going downhill, applying the brakes is important because otherwise it will gather momentum as it travels. Now the brakes in this context are supplied by the sugar within the jar, because as it's rolling, you may be able to see that the sugar cascades over. And in the example of the completely full jar of sugar, there is no room for the sugar to cascade over, and therefore minimal braking action. In the case where it is completely empty, there is no braking action either. In the case where the jar progressed least far and travelled slowest, the sugar cascaded over quite freely, and in the act of doing so, it provided a braking mechanism that slowed it down. The fact that this one was heavier and there was less room for the sugar to cascade over meant that the braking action was less effective in this case and more effective in that case. One can also talk of the centre of mass as being different in each case. The centre of mass was at the middle in both the empty and full case. The centre of mass was lowest down in this one and somewhat higher in this. And the lower the centre of mass of a body, the more stable it is, and greater stability in this case made for slower progress.